Hi, welcome to the pre-calculus lecture series. And we are in the chapter 5 right now. And chapter 5 is to all talk about is the trig functions. Our previous video, and we start to introduce the concept of a unit circle. And for this video, we're going to talk about, we start to introduce the 6 trig functions, and we use and also some good properties of those functions. All right. Okay, so now let's go to our lecture note worksheets and let's take a look. What are those 6 functions? So the first things here we're going to introduce is the definition of the trig functions of the real numbers here. So I want you guys pay attention to here. It's a real number, and then we'll take a look at the angles here. All right. So let's try to do a very brief review about the, in the section 1, we talk about the unit circles, right? So here's the unit circle. And then we say we have any real number, and this real number is a t's, right? So with t start, then we start to travel along the unit circles here. Then if t stopped here, then we call this is what? We call this is our terminal points, x, y's, right? Okay, so for the terminal points x, y, and so like, for example, we did a few simple ones here. We said, hey, if you travel pi over 2, then the terminal point will be 0, 1 here. Then we also have some special ones, like by solving the equation, like you intersect the line with the circles, right? Okay, so now today for this video, we're going to talk about the definition of the trig functions here. So the way we define this here, right? So we still, so here, this one's here, this is the t values, right? So we say if the t travel along the counterclockwise is positive, t is negative is counterclockwise will give you negatives here, okay? So from we know the terminal points, right? So it's where the t stop here. So we defined, so the definition of a trig function based on the real number t. So that's how we define, we say the sine t is equal to what? We say the sine t is the y coordinates of your terminal point. And then the cosine t is equal to the x. So it's equal to the x of your coordinate of your terminal point. And then for the tangent t, we defined as the y over x here. Of course, here x cannot be equal to 0. And then the other one here is cosecant t, we defined to be 1 over y, and the y cannot be equal to 0. And then we say the second t we define is 1 over x. Now, of course, x here cannot be equal to 0, right? And then we have this, we call it cotangent x, cotangent t, I'm sorry here. So it's a cotangent t. All right, so this is a cotangent t. This is equal to the x over y. And so, of course, the y cannot be equal to 0, right? So those are the trig functions, if we use the unit circle concepts here. And because they were defined by using the unit circle concept, so sometimes we call, those trig function, we call this the circular. Okay, so we call it the circular. We call it the circular functions, right? Because it's based on the unit circle concept. So now you say, oh, okay, so this is based on the terminal point. Then you said, some of you, I think, when we were in the high school, when you guys were in the high school for the geometry, so at the end of the geometry, they start to introduce the trig function. So of course, in the geometry level, they just give you the basic definitions about the trig functions, right? So that's why we say the trig function based on the angles here. So if you still remember, we say, okay, so this is the right angle. And then if this angle here is theta here, right? So we know the side face the right angle. This is what we call this hypotenuse. And this is, we call this opposite. And this is, we call this the adjacent, right? So based on our definition in the geometry, we said by using this angle definition, so we say the sine theta, we say this will be what is opposite over hypotenuse. Now we say the cosine theta is equal to what? We say is the adjacent over hypotenuse. Then we say the tangent theta is here, right? So it's opposite over adjacent, right? Then we say the secant theta, so it's equal to the hypotenuse over adjacent. Then we say the cosecant theta is equal to the hypotenuse over opposite. Oh, we forgot the cotangents, right? So cotangent theta, we say, is adjacent over opposite side. See, this is what kind of we learn from the geometry. So for a given theta, that means a given angle, and this is how do we define our trig function. So if you take a look at the definition of this one by the real number and by the trigonometry, then you will say, well, why they are so different? In fact, they are not. All right, so let me see. Let's try. We can combine this, right? So here, so this is my unit circles here, right? Okay, so now let's see why I say they are the same here. So for example, this is my T. I travel to here. Okay, so I will get a terminal point X and Y. So this point, right? So this is the point we call this X and Y, see here. Okay, so because of this, right? And then you see here, that if you connect this point to the center, you will get an angle, right? So you will get an angle here. So you can call this angle is angle theta, right? And then you can draw triangles here, right? So you can draw a triangle. I did not get a chance to write this. Okay, so here, this is the angle theta. Okay, now you can draw a triangle. So these triangles here touch here. So take a look at what is this side here. This is what? This is the value of what? Because this point, right? So this is the point of X. And what is this side here? This side is what? This side is the value of what? Of Y here, right? And then what is this green side here? The green side, this is a hypotenuse. And yes, this is a hypotenuse, but because this is a unit circle, so this hypotenuse is what? It's my radius, right? So radius is 1 here. So basically, we said T, this is what the angles, so we equal to this central angles here, right? So that's why we said take a look at the sine theta based on the angle. So if you take a look at sine theta, it's opposite over hypotenuse. So its opposite is Y, right? So let me put a color coding. So this is opposite is Y. All right, so this is X here, and the hypotenuse is 1. So, okay, so based on here, you see here, the sine theta, right, is the opposite over hypotenuse. So you will say, oh, opposite over hypotenuse. So what happens here? So it's Y over what? Y over 1 here, because the hypotenuse 1, right? So that's why I give you exactly the sine t, correct? All right, so now the cosine is adjacent over hypotenuse. So adjacent is this yellow side. So it's X, so it's X over hypotenuse. So hypotenuse is 1. So these two definitions, there's no contradictions here. All right, it's just like so because if you put your angle in the radians, that's what we're going to talk more in details in the chapter 6. So this arc length, you know, based on your geometry, this arc length is the central angles, right? Okay, so that's why, you know, from the, so if some of you still remember what you learned in the geometry's definition has no, you know, it's not contradict with what we by using the unit circles, right? So like sine x still is the opposite of hypotenuse, but it's my hypotenuse in the unit circle is 1 here. Okay, so let's take a look at the, okay, so let's take a look at the first examples here. So let's say find the 6 trig functions of the given functions here. So when the t equal to the pi over 3, so if you still remember from the previous, right? So we said pi over 3, right? So that means you start here, you travel pi over 3 here. Okay, so here, this is the, okay, so this is the, right? So the here is the terminal point. Terminal point here. What is the terminal point? It's pi over 3, right? So that means what is my x here? My x here is 1/2. And what is my y here is the square root of the 3 over 1/2 here. Correct, right? So that's what we did from the, you know, from the last ones here. So if you still remember, you know, if you don't remember, then go to, you know, review it. So that's why we say it's x equal to 1/2. Okay, so let's try to take a look. So that we say sine pi over 3 is sine what is y, right? So it's square root of 3 over 2. And then what is the cosine pi over 3? We say cosine based on my definitions here, right? Based on these definitions here, the cosine is x here. So what is the cosine here? Cosine is 1/2. And then the tangent pi over 3, tangent is what? Is y over x, right? So this is the square root of the 3 over 2 over 1/2. Then you flip it, and then you times it, give you square root of the 3. Then the cosecant theta pi over 3, so I'm sorry, cosecant pi over 3 is equal to 1 over y. So it's 1 over square root of the 3 over 2. Then you flip it, will be the 2 of the square root of the 3. And sometimes we want to simplify that, and or if you want, you can just leave it, or you know, you want to get rid of the square roots on the denominator, you can do this. Then the second pi over 3 will be what? Second is 1 over x. X is 1/2, so it's 2 here. Okay. Then the cotangent pi over 3. What is cotangent pi over 3? Cotangent pi over 3 is x over y, right? So cotangent is x over y. So it's 1/2 over what? Square root of the 3 over 2. All right. So when you do that, what is here? So this is 1 over square root of the 3. Now you can rationalize the denominator. So we'll give you square root of the 3 over 3. Okay, so this is part A here. Okay, part B. So now let's say, hey, now my pi is pi over 2. That means my pi travel here. I use my green ones here. Go go over here. Pi over 2 here, right? So here, this will be my what? Terminal point. So what is this terminal point here? Is 0 and what? And 0 and 1 here. Good. Okay, so now for the 0 and the 1. So now let's take a look at the sine pi over 2 is y, right? So it's 1. Cosine pi over 2 is what? X is 0. Okay, so now let's take a look. Okay, so the tangents here, tangent pi over 2 is equal to what? Is y over what? Y over x. I'm sorry here, this one. pi over 2. So y over x, so is what is zeros here, right? So the tangent pi over 2 is what is y over x. Oh boy, so what here? I got a 1 over 0, so it's what do not exist, right? So I cannot define the 1 over zeros here. Good. Okay, so now the next one I can define is a cotangent pi over 2. Cotangent pi over 2 is x over y, so it's 0 over 1, so it's 0. So that one is good. And the second pi over 2, what is the second pi over 2? Is 1 over what? 1 over x. So, whoa, so it's 1 over 0, so it do not exist, right? So this one we cannot define. Then let's take a look at cosecants here. Okay, so the cosecants here, cosecant pi over 2 is equal to the 1 over what? 1 over y. So it's 1 over 1. So it's equal to 1. Okay, so that is what we defined with the, with these 6 functions here, right? Okay, so now we used some special values of the trig functions here. So here, if you want to remember it, you can remember, or like remember we talked about in the previous video, we said this is the, this is the unit circles, right? Doesn't look like unit circle, but I mean that this unit circle is kind of a little flat. Let me try to redo it. Okay, so no, much better. I think it's much better. Okay, so now like we talked about in the previous video, we can just, right? So we can just create a table. We just need to remember the first, the number in the first quadrant. Now we were going to, so we start with here, right? So we start with t equal to 0. So then in here, let's try to put my terminal point, right? Terminal point x, y. And then here, let's try to put a sine t, and here's a cosine t, right? Okay, so the first point is 0. So what is my terminal point here? Is 1, 0, right? So my sine t will be 0, cosine t will be what? Will be 1 here. And then my next point, okay, so those are the special things we need to because kind of know. So the next one here is I'm going to travel, and this distance here is a pi over 6. So I have a pi over 6 here. So that's why I have a pi over 6. I travel the distance pi over 6. And then for this point here, right? So the terminal point for the pi over 6 will be the square root of the 3 and over 2 and the 1/2. Then the sine t, this is be 1/2, and this is square root of 3 over 2. Okay, so now the next important angles we travel is here. So we travel all the way from here to here, right? So this green arc I travel is pi over 4 here. Okay, so now I'm going to put a pi over 4, and then the terminal point is square root of 2 over 2, square root of 2 over 2. And so my sine t is square root of 2 over 2, square root of the cosine 2 over 2. Okay, then my next important angle is I travel to here, the blue one. So it's still start from beginning. I go all the way to here. Okay, so when I travel to here, then this is this is a pi over 3 here. So that's why I have a pi over 3. Then my terminal point here will be 1/2 and the square root of the 3 over 2. And then this one here, you're going to the square root of 3 over 2. This is 1/2 here. All right. Then the last point here, this is where I go to the, from here all the way to here, right? So the black ones here is pi over 2. So I travel the pi over 2 here. the pi over 2, my terminal point is what? Is 0, 1. Then you can see here, this is the sine, sine t is 1 and cosine t is equal to 0. So this is the special table. Like I said, as I know some of the, if you took the trig function in high school, your high school teacher might want you to remember all the angles. So in here, we don't have to. I think the only ones in here, just try to kind of remember the one on the what? On the first quadrant. Then for the other quadrants, we'll be able to, we'll be able to get it. And I'm going to show you how to get it. Okay, so this is the special value of the functions, and this one you might need to use a lot. And then the next things here, okay, we want to talk about the domain of the trig functions here, right? Okay, so in here, for the functions here, the domains here, if you take a look, right? So in here, I say the sine x, cosine x. So if you go back to my first, the first notes here, so we said, how do we define the trig function, right? So if you take a look here, the sine, cosine, do I have any restriction? No, I don't. I just say sine t equal to y, cosine t equal to y. But take a look at the tangent. Do I have any restriction? Yes, I said the value of the x cannot be what? Cannot be zeros, right? So now based on this, let's go back to here. Okay, so let's go back to here. Let's take a look. What is my domains here, right? Okay, so the domains here. So because the sine x and the cosine x, so there's no, so I say it's all what? All real numbers. There's no restriction. Then the next ones here, we say tangent x and the secant x. If you go back to there, we say the x cannot be what? Equal to zeros, right? Okay, so now we know the domains here is all the real numbers except, okay, so pi over 2 plus n pi's here, okay, for any integer. Okay, so take a look here, right? We said x cannot be 0. This is unit circles, right? So this is a unit circle. So I know if your terminal point stop in here, so this is 0, 1, right? So because the tangent is y over x, so I know this one cannot be true. Now, what is the other ones here? This one cannot be true, right? So this is a 0, negative 1. So I know I cannot do it. So because these ones here, both of them x equal to 0, so this is x equal to 0. So I can't. So that's why every, like n pi. So see here, they travel the n pi's here, right? So then every pi over 2, like the pi over 2, 3 pi over 2, then if you travel the whole circle, then this will be 5 pi over 2 is also cannot define, right? So that is how do we define the tangent. Then the last two is cotangent x and cosecant x. So this one we say y cannot be equal to 0, right? This is x cannot be equal to 0. So y cannot be equal to 0. What's that means here? And okay, so if you take a look, y cannot be equal to 0. This terminal, okay, let me use different color. So this terminal point, right? So this is y0. And what is here? This terminal point, this is negative y0, right? This is y. So we got y0s here, right? So every 0 in the pi, that will cannot make, right? So here we will say this ones here is all real numbers except what? Except at n pi's, right? So you cannot add a pi, 2 pi, 3 pi, so whatever you land on the x-axis, you cannot one. So that's how do we define the domains here. Okay, so the next one is also is quite important, the sign of the trig functions here, all right? So the sign of the trig functions here. So if you do, okay, so this is my X, Y, okay? So this is the first quadrant, right? So this is my first quadrant, this is my second quadrant, this is my third quadrant, this is my fourth quadrant here, right? Okay, so take a look here. Okay, so let's see the, okay, so for the signs here, depends how do you want to define. So the, okay, so you can say sine, cosine, tangent, and cotangent, secant, cosecant here, right? Okay, so now you can divide by the 4 quadrants here. Okay, so this is quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. So, okay, so quadrant number 1, x is positive, y is positive, correct? All right, so y is positive, x is positive. So this is a positive, positive. Tangent is y over x is a positive. Cotangent is a positive, positive, positive. Well, so like in the first quadrant, it's all positive. Okay, let's take a look. Next quadrants here, right? Next quadrants here, x is negative, right? So this will become negative. Y is still positive. So sine is y, right? So this is positive. Oh, what happened to cosine here? Cosine will become what? Negative. Then the tangent, right? Tangent is y over x. So y is positive, x is negative. What here? I have a negative. Then cotangents also, right? Cotangent is what? Cotangent is x over y. So this is negative. Secant is 1 over what? X. So this is negative. Then the cosecant is 1 over y. So what here? So this is a positive. All right. So now the third quadrant here. If you go to the third quadrant, so here, this is the third quadrant. Both x and y going to be negative. So sine is y, so it's negative. Cosine is y, x is negative. Okay, tangent is what? Tangent is y over x. So negative is what? It's a positive, correct? And then cotangent is x over y, negative is a positive, right? And then the secant is what? Secant is 1 over x, so it's negative. Cosecant is 1 over y, it's negative here, all right? Okay, so now the cosine, okay, then the fourth quadrant here. So let's take a look at fourth quadrant. This is the fourth quadrant. X be positive, y is negative, right? So sine is y, so it's negative. Cosine is what? Hey, cosine is x. Oh boy, cosine is what? It's positive. Then tangent, right? Tangent is y over x, so negative positive is what? Negative. Cotangent is x over y. Positive and negative will give you what? Negative. And the secant is 1 over x. So what is 1 over x? It's a positive. Then cosecant is 1 over y. So what is 1 over y here? Is negative, right? So I know the sine will be positive on the first and the second quadrant, and the cosine going to be positive on the first and the fourth quadrant, and the tangent will be, the positive on the first and the second quadrants here. Okay, so like if you highlight the first 3, so like this is the sine going to be positive here, and the cosine going to be positive here, and the tangent going to be positive here. So I know the quadrant number 1, all the trig functions is positive in the quadrant number 1 here. Okay, so these ones here, I don't want you to remember, you just understand the reasoning, and then you will know that, okay? Okay, so now let's take a look here. How do I find the trig functions here? So you say, hey, you told me you only need to remember the first quadrant special values, right? So how do you find it? Okay, I'm going to use example 2 to demonstrate. Okay, so to demonstrate this, so the step number 1 here. Okay, so if you still remember, so what you want to do here, you want to find the reference number. right? So the reference number, sometimes people call the reference angle. If you remember in our first video, it's always the terminal side to the x-axis. It's always positive, right? Okay, so now let's take a look here. So for the A's here, right? Okay, so this one's here. So this is a unit circle, right? So this is my unit circles here, right? So then I'm going to swing, all right? So swing the 2 pi over 3, right? So 2 pi over 3, that means I'm start here, and I go 2 pi over 3, so go all the way to here, right? Right, so I swing here. So this is 2 pi over 3. So, or you can say this is 2 pi over 3. So the reference angle, remember the reference angle is always to the what? To here, right? So it's always to the x-axis. So the reference angles here or reference numbers here for this problem is what? It's pi over 3, right? Because the whole thing is 3 pi over 3. It's pi. So this blue one is 2 pi over 3. So this is my reference angle is pi over 3 here. Okay, then the next thing here is tell you, see here. Okay, so that's what we find the step number 1. Then the step number 2, let's say here, find the sine. Okay, so find the sines, right? So in here, this is a cosine, all right? So cosine, okay, so this problem, this is a cosine here, right? So this is a cosine. I know the cosine is what? Cosine is the x values, right? So it's x. Then in here, you see here, this is your terminal point where it stop, right? So in the which quadrants here? This is the second quadrant. So it's negative. So I know my sign tell me my answers here going to be a negative. All right, so that's my step number 2. Then step number 3. So let's say find the value from the special value table. Okay, so the pi over 3 is here. So you go using the reference number, right? Okay. Okay, so basically this ones here will be equal to, okay, so because the sign is negative, so you say negative cosine. So the reference angle is pi over 3, so you say pi over 3 is here. Then you go to the special, the table we just created, so you find it's 1/2. Okay, that's how do we do this. Okay, now let's take a look at this one again. Okay, so tangent, all right, so the second one's here, right? So this is tangent pi negative pi over 3. Okay, so let's do the, okay, so let's try to do the unit circle. So this one's here, be careful here. Did you see here? This is negatives, right? So what you need to do, see here, you need to swing to where? Swing to this side, right? So it's a negative, it's a clock, it will be clockwise. So here, this is your angle. So this is what? This is negative pi over 3 here, correct? Okay, so the pi over 3, and we say is the terminal side with x-axis. So your reference angles here. So this is your reference number also is what? Is pi over 3. The reference is always determined by the terminal side and the x-axis. Okay, now let's take a look at the signs here, right? So step number 2, define the sign. Tangents, right? So we say tangent is what? Is y over x. Y in the quadrant number 4 is what? Is a negative number. But x in the quadrant number 4 is what? It's a positive number. So this is negative. So I know I'm going to have negatives. right? Okay, so now let's try to write this one to see what is this one equal to. So it's equal to a negative, because I just find the negative, the tangent, and the reference angle. So this is pi over 3. Okay, then you use your special table to find the pi over 3. What it will give you is a negative square root of the 3. Okay. All right, so that's good, right? So that always follow the same step. Okay, now let's take a look at the 19 pi over 3. So here, right? 19 pi over 4. Okay, 19 pi over 4. So here. So, okay. So first I do the 19 pi over 4 divided by 4. I will get 4 pi plus 3 pi over 4, right? I defined it, so I divide it. Okay, now let's start here. So this is, okay, because it's 4 pi, so this 4 pi, what's that mean? That means you turn the what? You turn the circle how many times? Twice, right? So you go boom, boom. So you do like this. You go boom, boom. Okay, now the third one is you go to the 3 pi over 4. So you go to here, right? Okay, so here, this is where you stop, right? So here, this is the, this is where you stop. Okay, so now this is, we call this 19 pi over 4. So you turn a whole circle twice, and then you stop at the 3 pi over 4. So what is the next one I'm going to do? Find the reference angle. So what is reference angle? Is always the terminal side to the x-axis and always positive. So my terminal angle, my reference angle is pi over 4. All right. Then the next thing is here, determine the signs, right? So determine the signs here. Okay, so this is on the second quadrant, right? So I know the sine is equal to what? Sine equal to y. So if this is on the second quadrant, what is the y values here? Y is a positive, so I have a positive here. Okay, so now I got everything set. Now we can write it. So this will be equal to what? It's a positive sine what? Reference angles, right? So this will be pi over 4, the reference angle. Then you go to your special angle. What do you find? The square root of the 2 over 2. So this will be, how do we find the, how do we find the values? Okay. So example number 3, see here. So this is just show you, like how do you use the calculator? Okay, so in your calculator, I believe most of the calculator, you can always have 2 choices here. You can either choose the degrees, all right? So typically put a degree, or you can choose the radian, RAD, all right? The degrees, okay? So whenever you choose degrees, you will see the way they write it, they will say sine 20 degrees, all right? So you will see a little degree signs here, all right? If like you don't see the degrees, right? If you don't have the sign, what's that mean? That means you have to use the radian setting, all right? So like in here, if you take a look, none of this have any degrees on top, right? So none of them have that. So you need to use your radian settings. You get that? Okay, so in here, because there's not a degree, so you need to change your calculator to the radian setting, okay? Then you just plug in the number into the calculator. Okay, so, you can try to plug that in to see you match my number or not. So this one I got is like a 0.8085. You should be very close. Now cosine 1.1, I get this number. I get this is like a 0.4536. Then cotangent 28 here, you can plug that one in, and you will get it's a negative 3.55. and then cosecant 0.69. So make sure you use the radians, right? Okay, so then you will get is approximately to 1.204 here. Okay, and so that's what you use the radian settings here, right? Okay, and then all right. So some people you say, hey, my calculator does not. All right, my calculator does not have the function for cotangent, for example. How do I do it? All right, so if your calculator does not have a cotangent, what you should do, because I know the tangents, right? Tangent t is equal to y over x, and the cotangent t is equal to what? X over y. So if your function does not have a cotangent, right? So what you need to do, see here, so you use what? You use tangent functions, right? After you use tangent function, then you use the key, we call this keys, right? X in like that means X inverse, that means you put it into the reciprocal. So the same ones here, you can put this is you use the sine functions, right? So you use the sine, right? Then you use the reciprocal keys here, X to the inverse 1, all right? Okay, so now let's take a look at another very important property, even odd properties here. Okay, so for the even functions, right? So the even function, that means negative and the positive will be the same here, right? Okay, so for the even functions here, okay, so let's take a look, see here. So the even function, okay, so the even function, cosine is even, right? Cosine t and secant t, okay? And the secant t, they are what? They are even. Why? Is because the cosine t is equal to x, right? Okay, cosine t, okay, so we said the cosine t, okay, so we said the cosine t is equal to what? We said the cosine t is equal to x here, correct? All right, so the x here, so you put the positive x and the negative x, what happened? Right, so they will give you the same number, right? So that's why we say it's cosine and the secant t, they are the even function. Then for the other here, okay, all the other function like sine t, right? And then tangent t, and the cotangent t, and the cosecant t, they are all what? They are all odd. Okay, so what do I mean, the even function? Remember, like we said, even, so that means you put the cosine negative t will be equal to the cosine, you put the t's here, right? And then the same way, the secant negative t is equal to the secant, you put the positive t. It's just like this ones here. We say because the cosine and the secant depend on the x here, right? So the other function, so what is the other function mean? That means if you have a sine negative t, this will be equal to the negative sine t. Tangent, you have a tangent negative t, we're going to give you a negative tangent t. Cotangent is a negative. Okay, so this one's here, that means that means this is a cotangent negative t. You will become, this is negative cotangent t. Then cosecant here, that means if you have a cosecant negative t, okay, so if you have a cosecant negative t here, right, this one will be equal to negative cosecant t here, all right? Okay, So now in here will be easier. So we say, hey, let's try to use the even odd function to find it. Okay, so these ones will become easy. I know the sign is odd. So that means this one is equal to the negative sign pi over 6. Then from the special table, pi over 6 is what? Is 1/2. So the answer is 1/2 here, right? Okay, so the cosine here, right? So this one's here, I say cosine is even. So cosine negative will be equal to the cosine what? Right? So this will be equal to the cosine pi over 4 here. So what is this one? The square root of the 2 over 2. Okay, so if you use the even odd, it's very easy. Okay, so now we have some very fundamental identities here. Like we already talked about some of it, we see that. So the first very common fundamental identity we call it is a reciprocal. Okay, we call it the reciprocal identity. Okay. So what is a reciprocal identity? We already see that. We say the cosecant t, right? So it's equal to what? The cosecant t is 1 over y, right? So it's 1 over sine t. The same for the secant t, we say it's 1 over x, so it's 1 over what? 1 over cosine t, right? And then we know the cotangent is x over y, so it's just 1 over what? Tangent t. And then we know the tangent t is equal to y over x, so it's sine t over cosine t. All right, so the same way, the cotangent t is just be equal to the cosine t over sine t. So even we have, right, 6 functions, but basically we only have 2. We have sine, cosine. All the other remaining 4 can be derived from the sine and cosine, right? So the next one here is very, very important one. We call it a Pythagorean. We call it a Pythagorean identity. Okay, this is a super, super important, the identity. We use this very, very frequently, all right? So this is very, very important. So what is the Pythagorean series here in the trig function? So we say the sine squared t plus cosine squared t is equal to 1. And then we also have tangent squared t plus 1 is equal to the secant squared t. Then the last one we have is 1 plus cotangent. Better write into the a little bit clear, not too messy. So it's a cotangent t square, okay, is equal to the cosecant square t, okay? So, okay, so be careful, you know, like a note here, okay? So this is super, super important, right? So this identity is super, super important identities, okay? All right. All right, so this is super important here. We put a lot of stars here, right? And also one other things I want to mention here is, you know, when you try to write the sine square t, so sine square t, this is why you put the squares here. This you can write is like this. Also, it's a sine t, the whole thing squares, right? But be careful, right? Do not write this. This is not equal to sine t squares, right? So do not write this, all right? This is not equal to. So you can write in this way, sine square, put the square in between, or you can put a parenthesis, all right? All right, so now let's take a look at our next ones here. And let's take a look at the example number 5. Okay. Okay, so let's take a look at the example. That's 2 examples here. Okay, so I said if cosine t, this is kind of the super important type of the example. Also, we're going to have you know, a lot of applications here, especially in the calculus 1 and the calculus 2. When you try to find the inverse of the cosine, those things, they will need to use this. Okay, they said if cosine t is 3, 5, and the t is in the quadrant number 4 here, find the value of all the, you know, all the value of the function t's here, right? Okay, cosine t is equal to 3/5 here, all right? So in here, so cosine t is equal to 3/5. So what I know about the cosine t here, okay? So I know the cosine t is what? Cosine t is x, right? So I know the cosine square t plus sine square t is equal to 1 by the identities, correct? Okay, so now cosine t is 3/5, so your square will be 9/25 plus sine square t equal to 1. So now you get the sine square t is equal to what? 16/25. So what is your sine t? Okay, sine t could be 4/5 or -4/5 when you take the square roots. Let's see which one is. Let's say this is on the 4th quadrant, right? So that means your terminal point. You go all the way, you stop here. Okay, so this is your terminal point on the 4th quadrant. So if a terminal point on here, so what is my x value? What is my y value here? My x value has to be what? It's positive. Then my y value is what? It's negative. And I know the sine. What is the y value of sine? Sine is the value of the y. So which answer is my answer? This one. So this one cannot be, correct? Okay, so now, okay, after we get this, then the problem is easy. Okay, so now I can say the tangent t from the identity, I know it's a sine t over what? Cosine t. So I can say it's a -4/5 over 3/5. So what is here? -4/3, right? Then I also know the cotangent t is just 1/tangent t, right? So cotangent t is -3/4, become pretty easy. Okay, and then the second t, I know from the identity is 1/what? Cosine t. So this is the 1/what? 3/5. So what is here is 5/3. Then the cosecant t is 1/, like a sine t, right? So the sine t is 1/-4/5. So what is the answer? -5/4, right? So those are my 6 trig functions. Like I would say, as long as you got the, you know, the first sine, cosine, you can get all the others, okay? Okay, so now let's take a look. Okay, number 6 here. The number 6, this one's here, the examples here, they say write the tangent t in terms of the cosine. Whoa, right? So tangent t in terms of the cosine and in the quadrant number 3 is here. Let's see here, how do I do it? Okay, so in here, that means I want the tangent t, right, to be some type of the functions here is a cosine t. All right, let's see how do we do that. How do we use identity? So first things I know by Pythagorean, so sine squared t plus cosine squared t equal to what? Equal to 1. Right, so now I know the sine squared t is equal to the 1 minus cosine squared t. So far, so good. Okay, so now the sine t, I take the square roots, so I can have a positive minus 1 minus cosine squared t. Okay, because this is what in the quadrant number 3 is here, right? Okay, so if this is a quadrant number 3, that means this quadrant. So this quadrant, x is what? Negative. Y is what? Negative, right? So the sign is negative. So what I need to take here, I need to take is a negative 1 minus what? Okay, so the negative, right? So I say it's 1 minus negative cosine square t, see here. All right. Now, okay, so you said, but I still don't have the cotangent. Oh, you use another, the identity. Then you say, hey, both sides I divide by cosine t. Let's see what happens here. All right, so the left-hand side, when you divide by cosine t, so it's sine over cosine, haha, what is this one? This one is a tangent t, right? So this is a cosine t, and the negative 1 minus cosine square t, right? So that is how I change the, tangent t in the terms of the cosine by using the identity, and also then use like the how to decide which one is positive, which one is negative signs, right? All right, so that's it for the section 5.2. It's kind of like lengthy sections, but it's very important section. We covered a few key things you definitely need to remember. Is the identity, fundamental identities, right? Then the second one here you need to remember or to understand how is the different sign in the different quadrant. So like is the trig function is positive or negative in which quadrants here. Then the last thing I think is very critical for you to learn that is the first quadrant, the special value of those 6 trig function in the first quadrants. All right, that's it. And so I know this is a very lengthy section, and I hope that you get a good understanding of this. All right, and I'm looking forward to talk to you in our next videos here. Okay, bye.